Have you ever wondered how an IP camera works? I haven't, but I have now, because today we're going to look at the OpenIPC firmware, which is from the OpenIP.cam project. This is Answer Everywhere, and we explore source code. We explore source code we've never seen before, and that's what we do. So somebody asked me to look at OpenIPC. It seems like this website doesn't exist. This code is from 6 years ago. Let's see if there's anything more recent. Is there anything else that's called OpenIPC? Is this the same? This seems to be different. I'm going to guess that this is where I should be. So let's start that again. Have you ever wondered how an IP camera works? Let's find out on Answer Everywhere. We're taking a look at the source code for the OpenIPC project, which is an alternative IP camera firmware from an open community. And we'll find out what they're up to. This is the firmware repo. And there may be other important repos. I'm going to guess it's mainly about firmware because it says alternative open firmware for your IP camera. And why would you want this? Well, maybe security. It's nice to know that if you have like a security camera that's recording footage of everything, it would be nice to know that the firmware is not doing nefarious things. In fact, we can search for the word nefarious just to catch them off guard. No, doesn't appear. All right, so let's find out. This is going to be broken down, it looks like, by, I was going to say camera, but maybe these are chips. I don't know what high silicon or grain media or GOK or full hand are. General, this is the second time, I think, in the course of all of these videos we've done that we see something like a general directory. We saw, what was it, generic, I think in OpenFOAM. General is kind of a strange name for directory, but maybe it means like common. Hello, Po boy, and welcome. Okay, so for under general, we have overlay package scripts. So overlay could be an overlay directory, probably not an overlay network. Package, I'm going to guess, is packaging stuff for the project. Scripts, who knows what could be in scripts? It could be build scripts. It could be scripts that run on cameras. Overlay looks like it has the POSIX root directory stuff. I forgot to set a timer, so let me just pop that up there. So we have etc libmdev. I forget what mdev is, but it's a dynamic thing that like shows up with devices. mdev. There's an mdev primer or primer if you're British. mdev has two primary uses: initial population and dynamic updates. Both require sysfs support in the kernel and have it mounted to /sys. So this is something about dynamic device support. And I don't know, is this an interesting place to be? We have automount.sh. This is some bash script that's going to handle mounting, I guess, probably in an mdev compliant way, one would guess. I don't see anything that we've got this autoconf.sh. Is that where the real stuff is? I'm not sure. I'm going to guess that this is not such an important directory, although maybe ROM has .empty, which I think makes git keep an empty directory. So I'm going to ignore general /overlay, and I think it's probably, well, hang on. General package has a lot of folders. And these folders seem to be broken down by some of the same words that I noticed in the like firmware folder, like Goke and what was it, High Silicon. And I also see something AWS-y, AWS WebRTC. So WebRTC is the like telephony protocol. Hey, thank you. What are we today? We are not building. Today we are examining. We are examining the source code of the for firmware for IP cameras. So this is maybe for supporting using your camera for WebRTC, I would guess. I don't really know what else would be in there. I just closed scripts by accident. Scripts has, these are bash scripts. I'm going to guess they're mainly for developers. I don't know what Aura HTTPD is. We have these MK files. I guess these are maybe CMake files. Okay. So I think general package is probably not the most important, although it does have a bunch of stuff. So we may come back to it. Maybe I'll just pop it out in its own browser frame. And then that leaves us with all of these folders for like things like BurX chip fullhan and BurX chip umbrella and Allwinner and Grain Media and Goke and Ingenic. I'm going to guess that these all have similar structures. Let's just peek at a few of them. We have board, B-O-A-R-D, as opposed to, you know, like a chipboard. We have configs. And then similar directories in these other ones. Okay, so let's find out what some of these are. How about Allwinner? And how about Goke? The Body Snatcher from Hell. That's probably not it. Allwinner Technology is a Chinese fabless semiconductor company specialized in mixed signal systems on a chip. Mixed signal systems on a chip, SoC. Okay, so these seem to be chips. Let's try Goke chip. Goke Microelectronics Co. Limited has its headquarters in Changsha and subsidiary offices in Chengdu and Shanghai. What are it's got both solutions and products. I thought solutions was like business speak for products, but they don't support HTTP, and we're not going to go there. But these are I think chips, and I think that they're all going to be like that. I don't know how to find out what's the most like popular of these, but we'll just pick one at random. We have rv1126.generic.config in chip rock chip. So I guess Rockchip is probably the manufacturer. And we see some config stuff. We're configuring whether CC is GCC, which is true. So I guess we're using GCC to build this. And this is like a bunch of like bash variables, probably for setting up the build system. What is config slub? Let's look up config slub. Slub. The basic philosophy of slub is very different from slab. Slab requires rebuilding the kernel to activate debug options for all slab caches. Slub always includes full debugging, but it is off by default. Slub can enable the debugger only for selected slabs. What? So it's something about memory management, I guess slab style memory management, and then slub is some variant on that. And these, I will guess, are all kernel configuration parameters. So maybe what we are doing is building the Linux kernel for different chips. Let's see if we can verify whether that's the basic strategy. Let's see. You can make a financial contribution at Open Collective, which seems like a cool place. And if you haven't explored that, we haven't really looked at it before, but maybe when I start seeing Open Collective, I'll start peeking through it a little bit. And More information about the project is available on the website and the wiki. What do we want? How about the wiki? The wiki is probably more geared for developers. The wiki is a GitHub repo. About the project, supported devices, detailed installation guide, installation on Goke, high silicon. Let's look at Goke. This is a list of Goke SoCs. So these are systems on a chip. System on a chip, as I understand it, is basically instead of just having a CPU or whatever chip, you kind of combine CPU and memory. And if you need a graphics processing unit, you throw that on there. So you, from a Verilog point of view, it's kind of like we'll just pound include everything onto the same thing and then print that on silicon. And I want to see just kind of like what the basic strategy is. Like, how do we... So historically, they only supported SoC manufactured by high silicon. They're starting to support more. The firmware comes as binary precompiled files for installation by end user. We provide full access to the source files for further development, et cetera, MIT licensing. Do we see the word Linux anywhere? Okay, so OpenIPC firmware uses buildroot to build its Linux distro and utilizes either Majestic, Mini, or Venk streamer. So this is useful. So it's a Linux distro. That explains why we see both the kernel and the overlay. If you're going to run Linux on the IP camera, I guess an IP camera, they have systems on chips, which are presumably some version of a general computer, general enough to run a standard off-the-shelf operating system like Linux with probably minor modifications. So I don't know what buildroot is. Let's find that out. Majestic, Mini, and Venk. These are probably all like video encoders for streaming the video. Mini Video Streamer is a part of the OpenIPC project. So this is a streaming software for high silicon IP cameras. It is malnourished and underloved. And it's the little brother to Majestic Video Streamer, which is what? Is it also part of OpenIPC? It is also part of OpenIPC. And then what is what? I thought Venk was a well-known encoder, but I don't know. Does it just stand for video encoder? Yeah, it's an NVIDIA thing, right? Oh, well, no. I think I was thinking of NVENC. So Venk without an N is just probably video encoder. Okay, so they've got some streaming stuff. Maybe it's worth looking at some of that, but I'm not sure. I'm not sure what my mandate is here. Here's buildroot. Buildroot is a simple, efficient, and easy-to-use tool to generate embedded Linux systems through cross-compilation. So we're building Linux. We're building it through cross-compilation. Why cross-compilation? So that I can compile on my workstation and run on a chipset that is not the one my workstation uses. So my workstation is some variant of x86-64, and I may want to build Linux to run on ARM or Goke or whatever these chips are. So let's pick another one of these and just poke around. I'll move it to its own thing here. So we have 3 kernel directories. I guess these are just different, maybe versions of the full hand board. And we get these configs, and I'm going to guess these are just full of Linux stuff. Configure kernel, configure have kernel LZMA. Let's just pick one of these kind of at random and see if it's not a kernel config thing. Configure block dev. I bet if we look this up, it will come to something kernel-y. Okay. So these are all, I think, they probably are shell variables, but I'm not sure. But I don't really know how the kernel is configured. It's been a while since I ran Gentoo or one of those distros that makes you compile your kernel from scratch all the time. Okay, so these are just like kernel configs. Fine. I get it. Okay, and then is there anything more interesting in the in the configs? Now we have def configs. We had configs in the board directory, but in the config directory we have def configs. So what is a light def config? We have what are probably more kernel configs. What if I search for light def config? I see Raspberry. Okay, so the .config file is not simply copied from your def config file. The motivation for storing def config in such a format is next. In def config, we can specify only options with non-default values. Okay, so this is, I guess the idea of def config is it's like a diff between the default config and the customizations you're making. As opposed to whatever the other format is, perhaps you have to specify the values even if they're non-default. I don't know. So these directories all are for configuring the kernel. So that means that we probably the real interesting stuff is probably actually in general, which I had concluded it probably wasn't. So let's take a look at well, data link might be interesting. How about GDB server light is going to be some, I guess, server for GDB for debugging. Why do you need a server? Presumably because you're likely debugging code running on, you want to debug code running on your camera and you want to control the debugger from your laptop or from your desktop. So that there has to be some remoteness to it. Here's lame OpenIPC. Lame is a video codec or encoder. I'm not really sure what its purpose is. Something about MP3s from the days of MP3s, I remember. Mini motors. Motors maybe for moving camera around. Opus, OpenIPC is probably related to the Opus codec, which I think is audio only, but maybe supports video. Or maybe it's only for the audio part of the stream. Sigmaster motors, I'm going to guess that's more motor stuff. I don't know what you Acme are or you QMI. QMI might be related to virtual machines. We have a web UI and some stuff. YAML CLI, I'm going to guess is for handling YAML. We have Wi-Fi broadcast. I'm going to bet a lot of this stuff is these are maybe external packages. And we have a joystick, perhaps for controlling what the camera is pointed at. Did they do that in Jurassic Park? They may. I don't remember. We have libcurl and libevent, which I recognize as external libraries. Logcat, I know is used by Android, for example, for logging information. Android is another embedded device. Embed TLS. This is a TLS implementation for embedded devices, kind of like OpenSSL for embedded devices. I don't know what Mini is. And what was it High Silicon? And then we'll just poke around the some of these directories. What's an SBIN? We have an IPC tool. Yeah, it's hard to know what in this will be interesting. This is like a full-on directory, but I'm going to guess is the overlay is not the most important thing. And then so what was the last thing in general? It was scripts. Okay. So we'll poke around at some of this package stuff. Here's data link. I don't know if this is an external file or not. So we have a telemetry something, no file extension. This is apparently a shell script. We've got some telemetry config in /etc. And start drone telemetry. Maybe maybe OpenIPC is sometimes used with drone cameras, or maybe they've copied this from some something that's primarily for drones. Telemetry drone and tweak sys. I'm not sure. Okay, so I see Goke here. So if vendor is open silicon, then prefix equals open. And then we're going to do a bunch of replacements with sed. Or rather, I guess we're removing unneeded modules using sed. And changing the frames per second using sed. And then we have some streamer thing that's going to do what? If we have majestic, I guess maybe we're going to favor the majestic encoder if it exists. Then whatever CLI is, presumably some command line thing. We're going to disable slow shutter, change the image contrast, change the luminance, and the bit rate and all that stuff. We're kind of configuring the video. Probably the CLI is talking to, is somehow configuring majestic and so on and so forth. Okay, so that's tweak sys. And let's see what else we have. Here's lame OpenIPC. We just have some makefile.mk, mk. Presumably we're going to download, here we go, lame OpenIPC site. We're going to go to SourceForge. We're going to go to SourceForge and presumably download lame and build it. Let's see if we can find lame software. The lame is a software encoder that converts digital audio into the MP3 audio coding format. So it's an MP3 encoder, I think. Linux patcher is probably some external thing too. Or maybe not. Linux patcher.mk does what? We've got some image name for the Linux thingamajiggy. We've got this variable about whether we should apply patches. Let's see if there's a URL. No, this is just, I guess, configuring locally through this makefile whether and how to patch. For example, define Linux patcher Linux config fixups. We're going to, I guess, set it to the output of Linux patcher config theros and timers. So we're fixing up something. I don't know quite what, but something about timers and theros, which I think makes chips, right? Or is it maybe the name of a driver? Something about Qualcomm chips. What is the function of Qualcomm Atheros? It's a highly integrated wireless local area network WLAN system on a chip. Okay, so it's like wireless driver, essentially. Here's motors.meek. Motors build commands. We have cam high motor, cam he motor, I2C motor, XMK motor, XMUART, and Ngenic motor. So we're really just calling out to other motor directories. And this must be the permissions. Let's see if we can find one of these other motor directories. Motorin. Oh, there were. I thought I saw them, but they don't seem to be in the root directory. Is there something wrong? Oh, whole words. Yeah, let's take that off. not an overlay in package. There we go. Sigmaster motors. Let's try Sigmaster motors. We have a source. So we've got one file, motor.c, which has some sequence of, I'm going to guess these are like maybe on off for motors or something. Or maybe these are just pins, like what we're going to write to the pins, because we have this GPIO thing. Let's see where sequence is used. Static int motor control is going to take a pointer to GPIO and a count. We're going to iterate over the count. And as long as the index is less than the count plus the sequence count, then we're going to iterate over the for something or others and write the sequence thingy for GPIO. So I think that these are like pin states. I have failed to mute my phone, which is a great shameful act, but I've just muted it. Okay. All right. So that's motor stuff, something about pins and embedded devices, you know, that sort of thing. So here's OpenIPC. This must be the codec. Let's just search Opus codec. We've seen LAME, which I think is the MP3 codec. Opus is a totally new, royalty-free, highly versatile audio codec. I think it's like free. Is it free and lossy? It's maybe like the lossy version of FLAC. It's published as a free software. Okay, so it's free software. Cool. UACME. I don't know what UACME is. We've got some patch, which means probably that we're going to download something and patch it. We have 1 minute left. Let's just fly through and see if we see anything that looks like it has a lot of flavor to it. So WebUI has a few files, including Etsy, which has an HTTPD conf, which I guess means we're running Apache. initd, and we've got we have a Telegram bot. Why would we have a Telegram bot? Yeah, so we've got this HTTPD thing. I guess, does this mean Apache is running on your camera? And how do we know? Apache is ancient, and I'm positive there are ways to secure it, but I don't know if there's enough in here to make sure that the server is secure. I just don't know enough about how Apache is structured or how to configure it. So that's kind of the question I have. If I loaded this onto my camera, would it be communicating with Telegram, and would the Apache config be secure? Assuming the web UI is running on the camera, so I could do things like configure it. This is a Telegram daemon. It's got some start-stop stuff and some PID. And the daemon is telegram-bot/sh. Let's see if that's in this directory. I'm not sure. Telegram bot and send to Telegram. Notice and link. Please consider adding a notification to the Telegram bot page that the bot is an add-on to the Telegram sender, and on the Telegram sender page, add information about the possibility to configure the bot with an internal link to whatever that is. Some Telegram CGI file. Huh. Rewrite Telegram bot. So there's some pull request, I guess, or bug to rewrite the bot. I don't really feel like I see the bot itself. Maybe that's here. This is here, Telegram sender. You've got some token, which I hope is not supposed to be a secret, although it looks somewhat secret. And we're just going to curl to the Telegram API to call send message with some chat ID. And where do we use this token? So maybe the token is really just the name of the bot. Let's try. See if we can go here. I just want to see if this is like a welcome page. All right. So this is presumably meant to only be operated via via curl. What if I get rid of this colon? Yeah, I don't know. Okay, so something about a Telegram bot, it's a little bit surprising to me. But you can send Telegram stuff. I mean, I can see why you would want to communicate to the outside world. I understand why some people like Telegram. It's a little bit strange to me because they are a little bit of a strange organization. So you would probably want to make sure that you either, if you don't trust Telegram, you would maybe want to remove that or somehow like set the camera's DNS for telegram.com or whatever to point to nowhere. And that's where I will leave that. We are out of time. That is OpenIPC. So it's an interesting project. It's an interesting project. The TLDR, from what we've seen, is that they are going to run Linux on these system on a chips. There's probably a ton of work there to just make sure, even if we started with stock Linux and only had to choose among like the existing Linux config options, there's a lot of work to make sure that we've chosen the right ones, that there are no bugs. These occasionally with some of these embedded Linux projects, you will run firmware and you'll find that like things don't quite work as expected because the firmware that came from the factory has like special code to work around like known bugs in the hardware or whatever. And all of that stuff is like super hard to pin down and debug. And I suspect that that's a lot of what the OpenIPC people are doing, is just making sure that there's a really good experience on the camera and that they're shipping at least with like the kind of nice features that that the standard IP camera firmware would use. So that's really cool. I have no idea whether like what the security posture of it is. I have no reason to think that it's insecure, but I would want to, before I ran this on my own cameras, I would want to know a little bit about like what's known about HTTPD and their configuration for it, and I would probably want someone who's a security expert to like look over the code and to verify that things look reasonable, because you might be using this to record sensitive things like your children or whatever. Okay, so that's OpenIPC. Let's move along to another repo.